All right, in this video, we want to take a look and figure out how can we prove that two functions are inverses of one another. So the way that we are going to do that is using function composition. And hopefully we still remember what function composition is, right? That's still chapter 1. We need to show f of g of x and g of f of x. So we are going to use an example. In our last video of just intro to inverses, we had to find the inverse of f of x. Well, we are going to use that same example here to prove that these two functions are inverses using function composition. So if you remember, we were given f of x equals negative 2x plus 4. We found that the inverse was inverse f of x equals x minus 4 divided by negative 2. As you can see, I just changed that and wrote it as g of x. All right, I just wrote it as g of x there. So what we want to do is find f of g of x and find g of f of x. At the end, we are going to see that they should both be equal to the same thing, and we're going to find out what they should be equal to in a second. So for f of g of x, we're going to do this one in green, I guess. We take g of x, we plug it in for every x in f of x, so negative 2 g of x plus 4. Give myself a little more room. Negative 2, and then I plug in parentheses, x minus 4 over negative 2 plus 4. Well, here I can see I have negative 2 times x minus 4 divided by negative 2. Well, this negative 2 times and divided by are just going to cancel each other out, so I'm left with x minus 4 plus 4. Well, x minus 4 plus 4, the minus 4 and plus 4 cancel out. I'm left with just x. So I get f of g of x is equal to x. What about g of f of x? So g of f of x, I'm going to take f of x and plug it in wherever I had an x in g of x. That's equal to negative 2x plus 4. I like to plug it in parentheses just so I can see where I'm plugging it in. I get negative 2x plus 4 minus 4. Well, plus 4 minus 4 just leaves me with negative 2x, still over negative 2. And negative 2x divided by negative 2 is just x. So what do we find? We find that if two functions are inverses, so if two functions are inverses, this must be true. F of g of x has to equal x, and g of f of x equals x. So I rewrote that here. I'll put an arrow. This is always true if f of x and g of x are inverses. So it's always true if f of x and g of x are inverses. Well, let's think about why. When we think back to our kind of loose definition of inverses, we said that they were two functions that undid one another. All right, so let's say that we start with x. Okay, you start with some value, just x, and you plug it in, right? You plug it in, you're going to get out, for this example, we'll say we get out g of x. Well, then you're taking g of x and you're plugging it in to f of x. And we said that f of x is going to undo g of x. So it's just going to bring us right back to our starting point. If I do f of that g of x, well, it's supposed to undo g of x, so it should bring me right back to where I started, which was just x. Same thing for g of f of x. We start with x, we do f of x, and then we are doing g of that f of x. Well, if g of x really undoes f of x, it should bring us right back to where we started, which the value we started at was x. So that is why f of g of x equals x and g of f of x equals x if f of x and g of x are inverses.